All right, 4.5, solving quadratic equations by finding square roots. All right, we're not going to be solving quadratic equations at this time. First of all, we need to understand what a square root is. Okay, square root is an inverse. All right, probably doesn't mean much to you right now, but it will eventually, of raising a number to the power of 2. All right, so for example, if I have r, by raising it to the power of 2 is equal to s. So then the inverse of it, in other words, to go backwards, I will take r is equal to the square root of s. All right, that's pretty much what it means. It doesn't mean a lot to you right now. So for example, 3 squared is equal to 9. 3 times 3 is 9. Okay, so therefore 3 is equal to the square root of 9. All right, that doesn't seem much, but we will be doing examples and it will clear this up. But there's some aspects of radicals you need to know. This symbol right here is called the radical. All right, back in the 70s, they would like this lesson because it's so radical. All right, don't worry, I won't quit my day job. The radicand, all right, so if the square root, or this right here, if this right here is the radical, what's inside is called the radicand. So for example, we have the square root of x plus 5. Well, that means here's the square root, or the radical. What's inside the radical is called the radicand. So x plus 5 is the radicand. All right, so in this lesson, you're going to be able to use properties of square roots. First thing you need to know how to do is simplify radicals. All right, so this is how you do it. This is a square root. All right, square root means something that I take to the power will give me 25. All right, that's what I was asking here. What is it that I square it, gives me 25? In other words, what times itself gives me 25? And that would be 5. So that's your answer. Right? Square root of 9. Same thing. What times itself gives me 81? Well, is it 2? Well, 2 times 2 is 4. So nope, can't be that. What's 3 times 3? That's 9. So it can't be that. 4 times 4 is 16. Nope. 5 times 5 is 25. We did that here. 6 times 6 is 36. 7 times 7 is 49. And you'll notice that in this case, when we get to it, it'll be 9. Now, I don't put 9 times 9 because I want the square root of 9. In other words, I just want the one number. Square root of 169. Well, if 9 times 9 is 81, that means it has to be larger than that. So what's 10 times 10? 10 times 10 is 100. So it's not it. So I have up. 11 times 11 is 121. 12 times 12 is 144. And 13 times 13 is 169. So therefore, that will be 13. Okay, so that's how you simplify. In other words, ask yourself, what times itself gives me that number inside? Is it 5 times 5, 4 times 4, and what it is, you just want one of them. Don't write both, you just want the one. All right, so let's move on. All right, here's another property. If you look inside, if you look at the radicand, if it's all multiplication and division, then you can pull it apart. In other words, I can do the radical of A and the radical of B. So I can simplify these radicals, and after I do that, then I can multiply. All right. So how does this help us with these? Well, if you notice, there's let's I don't know, let's try it. So 400, is that a perfect square? In other words, can I say what times itself gives me 400? Is there a number times itself that gives me 400? Is it 20? Yep, so this is 20 times 20. That gives me 400, so my answer for this one will be 20. All right, let's look at number 5. All right. Now you notice 24, there's no number, there's nothing that says something times itself gives me 24. It's impossible. Okay, so what, where? That's supposed to be 24. All right, so that means what perfect square that can go into 24? All right, now remember your perfect squares. I'll write them over here. Perfect squares is 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. You should be recognizing how I got this. This is 2 times 2. This is 3 times 3. This is 4 times 4. This is 5 times 5. That's 6 times 6. 7 times 7. 9 times 9. 10 times 10. These are your these right here are your perfect squares. All right. My question is, which one of these can go into 24 evenly? In other words, 24 divided by one of these that will not give me a decimal. All right. Well, that's 4 times 6. Right? 4 times 6 is 24. All right. Now you see how the property applies? All right. Well, by the property I just showed you above, I can rewrite this as the square root of 4 times the square root of 6. Well, the square root of 4, that's 2 times 2, so therefore I can write it as 2. Radical 6, it's not one of these. So therefore, just leave it as 2 radical 6. And there's your answer. 44. Well, this is 4 times 11. All right. So you notice I'm just rewriting the radicand. The radical stays the same, but I'm just rewriting what's inside. All right. So now I can pull it apart. Well, we know the square root of 4 is 2. And then we have the square root of 11. And we're done. All right, let's go back up to number 7. Number 7, all right, what can go into 60? Let's see, 60 divided by 4. All right, that's 15 times 4. All right, so put that in radical. Well, you can rewrite it as 4 times 15. So that means by that property, I can do it as radical 4 times radical 15. We know square root of 4 is 2, and then radical 15. And there's your answer there. Now let's look at number 80. All right, here, let me clean this up a little bit. All right, 80. Let's see, 80 divided by 4. Okay, that's 4 times 20. All right, but is that the largest one? All right, well, let's see. 4 words, can 9 go into 80? So 80 divided by 9 gives me 8.88888. So that doesn't work. Let's try 16. 80 divided by 16. Ooh, that's 16 times 5. So that's even bigger. So I'm not going to use this one. And you'll notice after you do a few more, nothing else goes into 80 evenly. So that means I can take this now, pull it apart. Square root of 16, we now know is 4 times 4. In this case, it would be 4, and square root of 5. And there's your answer. All right. Let's look at multiplying and then simplify. All right. The property is this. Now we're using the exact same property. Now we're going backwards. Since this is multiplication, I can go ahead and do 3 times 12, and that gives me 36. Oh, and 36 we know is 6. Okay. Here I can rewrite it as 5 times 8 now. All right, see, this is multiplication. If this was a plus or minus, I won't be able to do it. It has to be multiplication and division. So 5 times 8 is 40. All right, now that's not a perfect square, but we know we can rewrite it as 4 times 10. So that means square root of 4 times square root of 10. Square root of 4 gives me 2, and then we got square root of 10. And there's your answer there. Number 11. We got 13 times 13. Well, I'm going to stop right there. When these two numbers are the same, your answer will always be that number. Because if you do 13 times 13 is 169, well, the square root of 169 is 13. So you can use a calculator if you want. But if these two numbers are the same, and I am multiplying, then your answer will be that number. So number 12. These are the same. And since I'm multiplying, my answer will be that number. Simple as that. All right, let's look at a couple more. All right, now you notice here we got some that are inside and some that are outside. So how do we write that? Well, what's on the outside stays on the outside. What's on the inside I can put together. So 3 and the 2 are inside the radical, so I can put that inside together. And therefore I get 5 radical 6. Because 3 times 2 is 6. All right, for this one, be 7 on the outside. I got a 6 and a 3 on the inside. Well, that becomes 7 square root of 18. All right, that is an answer, but if you leave your answer like this, I'll take a point off. Okay. Because 18 can be simplified. All right, so I have a number out here. 18 I can rewrite as 9 times 2. So therefore I can rewrite as 7 times the square root of 9 times the square root of 2. Well, that's 7 times the square root of 9. So square root of 9 is 3. So we got 7 times 3 times the square root of 2. So therefore 7 times 3 is 21 times the square root of 2. And there's your answer. All right, let's finish this up. We have about 5 more examples. Now we're dealing with division. So if you look here, or division, all right, and same thing. You can take the top, do the radical up top, and then you can do the radical on the bottom. So you can do these separately, okay? So that means I can do this as radical 16 over square root of 25. Well, by now you should recognize that square root of 16 is a perfect square. That's 4 times 4, so your answer is 4. 25 is 5 times 5, so your answer is 5. Okay. This one is 7, square root of 7 over square root of 9. This can't be simplified, so we just leave it alone. 9, that's 3 times 3, so therefore the answer is 3. All right, so you can have radicals in your answers here. Okay, next one. I can rewrite this as square root of 1 over square root of 9. So that's 1 times 1, which is 1. 9, square root of 9, that's 3 times 3, so it's 3. So your answer is 1/3. Number 18, pull it apart. Okay, there's nothing you can do with the radical 3. But 16, that's 4 times 4, so that becomes 4 on the bottom. So there's